When a 200 amp double pole double throw transfer switch, listed for service entrance use, is installed between the electric meter and the main panel in an existing home, the grounded conductor and the equipment ground should be bonded together in the transfer switch, just as they are in the main panel. According to the National Electrical Code, in a service entrance transfer switch, the grounded conductor and equipment grounding conductor shall be bonded together at the first point of connection to the non-portable equipment grounding conductor. When a transfer switch is installed, it becomes the first point of connection for the electrical system after the utility meter. To ensure proper grounding and safety, it is crucial to bond the grounded conductor, or neutral, and the equipment grounding conductor, or ground, together. This bonding provides a low impedance path for fault currents, preventing the accumulation of static charges and ensuring the proper operation of protective devices. The main panel is typically located after the transfer switch. The bonding of the grounded conductor and equipment ground should be made using an appropriately sized grounding bus or terminal block elaborated for the full ampacity of the switch. The connection should be accessible for inspection and maintenance. The purpose of bonding the grounded conductor and the equipment grounding conductor in a service entrance is to create a low impedance path for fault current to return to the source. This low impedance path is essential for the proper operation of overcurrent protective devices, such as circuit breakers and fuses. Without a proper bond, fault currents may not be high enough to trip the overcurrent protective devices, which could lead to a dangerous situation. Grounding and bonding are critical for electrical safety. The equipment grounding conductor provides a path for fault current to flow back to the source, stripping the overcurrent device and energizing the circuit. The grounded conductor, when bonded to the equipment grounding conductor at the service entrance, ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of electric shock. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding electrical systems. Article 250 of the NEC covers grounding and bonding requirements. It is important to follow these requirements to ensure the safety of the electrical system. When installing a transfer switch, it is important to ensure that it is properly grounded and bonded. The transfer switch should be listed for service entrance use, and it should be installed according to the manufacturer's instructions and the NEC. The grounded conductor and the equipment grounding conductor should be bonded together in the transfer switch, using an appropriately sized grounding bus or terminal block. The connection should be accessible for inspection and maintenance. Here are some key considerations when grounding and bonding a transfer switch. Firstly, the size of the grounding electrode conductor should be determined based on the size of the service entrance conductors. Secondly, the grounding electrode conductor should be connected to a suitable grounding electrode, such as a ground rod, a metal water pipe, or a concrete encased electrode. Thirdly, the equipment grounding conductor should be sized according to NEC Table 250.122. based on the rating of the overcurrent protective device protecting the circuit. Fourthly, all metallic parts of the electrical system, including the transfer switch enclosure, should be bonded together using equipment grounding conductors. Fifthly, the bonding connections should be made using listed connectors and should be accessible for inspection and maintenance. Sixthly, it is important to verify the grounding and bonding connections using a ground impedance tester to ensure that the impedance is low enough to allow for proper operation of overcurrent protective devices. And seventhly, any questions, it is always best to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable codes and standards. The importance of proper grounding and bonding cannot be overstated. It is essential for the safety of people and property. By following the NEC requirements and best practices, you can ensure that your electrical system is properly grounded and bonded. The transfer switch serves as the initial connection point within the electrical system after the utility meter. Therefore, it is designated as the service entrance. In this role, it must comply with specific regulations governing grounding and bonding. These regulations are primarily outlined in Article 250 of the National Electrical Code. The grounded conductor, commonly referred to as the neutral, plays a vital role in carrying current back to the source under normal operating conditions. The equipment grounding conductor, often called the ground wire, provides a path for fault current to flow back to the source in the event of a fault. When these two conductors are properly bonded together at the service entrance, it creates a low impedance path for fault current. This low impedance path is essential for the prompt operation of overcurrent protective devices, such as circuit breakers and fuses. A low impedance path ensures that a fault current will quickly reach a level high enough to trip the breaker or blow the fuse, effectively cutting off the power to the faulted circuit and preventing potential hazards such as electrical shock and fire. Without proper bonding, the fault current may be limited by the impedance of the grounding path. This can result in a current level that is insufficient to trip the overcurrent device, leaving the circuit energized and posing a significant safety risk. The main panel, which typically houses the circuit breakers that distribute power throughout the home, is usually located downstream of the transfer switch. This means that the transfer switch serves as the first point where the grounding and bonding requirements must be met. The NEC mandates that the bonding of the grounded conductor and the equipment grounding conductor be achieved using an appropriately sized grounding bus or terminal block. This bus or block must be capable of handling the full ampacity of the transfer switch. The ampacity of the switch refers to the maximum current it is designed to carry continuously. Therefore, the grounding bus or terminal block must be rated to withstand this level of current without overheating or failing. Additionally, the grounding bus or terminal block must be equipped with a lug that is also rated for the full ampacity of the switch. The lug is the point where the grounding conductors are physically connected to the bus or block. It must be securely fastened and capable of maintaining a reliable connection under normal and fault conditions. Accessibility for inspection and maintenance is another crucial requirement. The grounding connection must be readily accessible for visual inspection and periodic maintenance. This allows electricians to verify the integrity of the connection and ensure that it remains secure and effective over time. Regular inspection and maintenance can help prevent corrosion, loosening, or other issues that could compromise the effectiveness of the grounding system. The National Electrical Code, or NEC, serves as the definitive standard for electrical installations in the United States. It is regularly updated to reflect the latest advancements in electrical technology and to address emerging safety concerns. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Article 250 of the NEC is dedicated to grounding and bonding requirements. This article provides detailed guidelines on how to properly ground and bond electrical systems to minimize the risk of electrical shock and fire. It covers various aspects of grounding and bonding, including the selection of grounding electrodes, the sizing of grounding conductors, and the methods of connecting grounding conductors to equipment and structures. The NEC also specifies the requirements for grounding and bonding in specific types of electrical systems, such as those used in residential, commercial, and industrial buildings. It addresses the unique challenges and considerations associated with each type of system. When working with electrical systems, it is crucial to have a thorough understanding of the NEC requirements and to follow them meticulously. Failure to comply with the NEC can result in serious consequences, including electrical shock, fire, and property damage. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the NEC in some areas. It is important to be aware of and comply with all applicable codes and regulations. Proper grounding and bonding are essential for electrical safety. They provide a path for fault current to flow back to the source, tripping the overcurrent device and energizing the circuit. They also help to minimize the risk of electrical shock by ensuring that all metallic parts of the electrical system are at the same potential. By following the NEC requirements and best practices, you can create a safe and reliable electrical system that protects people and property. Grounding refers to connecting the electrical system to the earth. This connection provides a reference point for voltage and helps to stabilize the electrical system. Bonding refers to connecting all metallic parts of the electrical system together. This creates a low impedance path for fault current and helps to minimize the risk of electrical shock. The equipment grounding conductor, or EG, is a critical component of the grounding system. It provides a path for fault current to flow back to the source. The EGC must be sized according to the rating of the overcurrent protective device protecting the circuit. The grounded conductor, also known as the neutral, is another important part of the grounding system. It carries current back to the source under normal operating conditions. The grounded conductor is typically bonded to the equipment grounding conductor at the service entrance. The grounding electrode is a conductor that is used to connect the electrical system to the earth. Common types of grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. The grounding electrode conductor is used to connect the grounding electrode to the electrical system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Ground clamps and lugs are used to make connections between grounding conductors and equipment. These connectors must be listed for grounding purposes and must be properly installed. Grounding and bonding tests are performed to verify the integrity of the grounding system. These tests can identify problems such as loose connections, corrosion, and improper grounding electrode installation. A ground impedance tester is used to measure the impedance of the grounding path. This test can help to identify potential safety hazards. The transfer switch is a device that allows you to switch between two different power sources, such as utility power and generator power. Transfer switches are commonly used in homes and businesses to provide backup power during power outages. When installing a transfer switch, it is important to ensure that it is properly grounded and bonded. A transfer switch should be listed for service entrance use and should be installed according to the manufacturer's instructions and the NEC. The grounded conductor and the equipment grounding conductor should be bonded together in the transfer switch using an appropriately sized grounding bus or terminal block. The connection should be accessible for inspection and maintenance. Here are some common grounding mistakes to avoid. Firstly, using undersized grounding conductors can limit the effectiveness of the grounding system and increase the risk of electrical shock. Secondly, failing to properly bond all metallic parts of the electrical system can create a potential shock hazard. Thirdly, neglecting to test the grounding system can allow problems to go undetected. And fourthly, ignoring the NEC requirements can lead to unsafe electrical installations. The transfer switch, often a double pole double throw or DP/DT switch, must be appropriately rated for the electrical service. A 200 amp switch, for example, is designed to handle a maximum continuous current of 200 amps. Installing an undersized switch can lead to overheating, damage, and potentially a fire hazard. The listing of a transfer switch for service entrance use indicates that it has been tested and certified to meet the stringent requirements for use as the main point of connection to the electrical system. This listing ensures that the switch is capable of safely handling the voltage and current levels associated with the service entrance. The location of the transfer switch between the electric meter and the main panel places it squarely within the service entrance. This location necessitates strict adherence to the NEC requirements for grounding and bonding at the service entrance. The act of bonding the grounded conductor and the equipment grounding conductor creates a single point where these two conductors are electrically connected. This single point bond is essential for establishing a low impedance path for fault currents to return to the source. The low impedance path allows for the rapid clearing of faults, preventing potential hazards. The grounding bus or terminal block used for bonding must be appropriately sized to accommodate the grounding conductors and must be securely mounted within the transfer switch enclosure. The lug used to connect the grounding conductors to the bus or block must also be appropriately sized and securely fastened. The requirement for accessibility of the grounding connection is critical for ongoing maintenance and inspection. The connection should be easily accessible without requiring the removal of other components or the use of specialized tools. Regular inspection of the grounding connection can help to identify any signs of corrosion, loosening, or damage. Promptly addressing any issues can prevent potential safety hazards.